Okay, cool. So here's the difference between aldol condensations and nucleophilic acyl substitution. They both happen with carbonyl compounds, of course. So draw a line here. This is going to be the aldol condensation. And this is going to be the nucleophilic acyl substitution. Okay. All right. I'm going to use exactly the same carbonyl compound. I am going to use an ethyl, some type of. I'm going to go ahead and use like a phenyl group here. Phenyl. Okay. All right. I'm going to have a carbonyl compound there. Okay. So now, notice that I have, obviously this is a CH2, CH and CH, and this is now a methyl group. And I will have exactly the same thing on this side. I'm going to have a phenyl group. It's going to go up to a carbonyl. Carbon is going to go down to a CH2. And then it's going to have a methyl group there. Nucleophilic aldol condensations. Aldol condensations occur with base. Okay? With a base, alright? Whenever there is a base near a carbonyl compound, bases near carbonyl compounds will go for the alpha hydrogens. These are the alpha hydrogens. These are the beta hydrogens. The ones that will go with this method are the beta hydrogens. Okay, so this is the alpha hydrogens. Bases will go with the alpha hydrogens. We'll abstract them. These electrons will go here, and they will kick these other electrons up here, and this will yield a structure like this. Will yield my phenyl group, an oxygen, and now that oxygen's got an extra pair of electrons there, so now it will be negatively charged. I'm going to go down here. I will have a double bond here from these electrons, and now I will have obviously this extra hydrogen that was left up there. So I'm going to have my carbon here, that extra hydrogen, right? The electrons from this hydrogen went to form the double bond, and I have a methyl group there. This will be in resonance whenever these electrons come here and kick, reform my carbonyl and kick this double bond out of the way. I will have this pH, I will have this. Now again I have my carbonyl compound, but now I will have obviously this is just going to be my methyl, and this is going to be the bond to that hydrogen, and I will have an extra pair of electrons here giving me a negative charge there. This is an aldol condensation. Aldol condensation, again, where I have a carbonyl compound in the presence of a base. The base will always go for the alpha carbon, for the alpha hydrogens, rather. And this will be a structure in resonance. So these two things are gonna go hand in hand. Okay. When we talk about the nucleophilic acyl substitution, nucleophilic acyl substitution is usually in the presence of an acid. All right. So let's see if we can use a different color here. I don't have very many colors. Let's try to use a black here. Okay. So there will always be an acid here. Okay. And remember that this oxygen has electrons there, and those electrons are going to go ahead and grab that proton there. And when they grab the proton, we will now have our phenyl group we will have our double bond to the oxygen, but now the oxygen will be bonded to that hydrogen there. Okay? and it will have a positive charge because it now has 3 bonds to it. Again, I will have my carbon to my 2 hydrogens here and my methyl group there. Okay? Now what is going to happen? What is going to happen is now that this electron, let me double check before I mess up this video. Okay, exactly. So what is going to happen is that these electrons now are going to come here to this oxygen to relieve that negative charge, but now we're going to have a positive charge down here. Okay, so these are now my 2 resonance structures. Sure. Yes, 2 resonance structures that we get. We have 2 resonance structures that are now my phenol. That goes here. I will now have a bond, an alcohol there, okay, and I will have carbon, hydrogen, hydrogen, and a methyl. But now this carbon only has 3 groups to it. Therefore, it is now a carbocation. Okay. Now notice that I have these 2 resonance structures. There is really nothing much that happens to this one because this is a very unstable configuration, but this is a carbocation, and it will attract any nucleophiles that are on the way. So if I have, say, okay, so now I have this, and assume that we now have a nucleophile, like a floating chlorine ion, right, or a bromine ion, or a fluorine ion in solution, even an OH. This is very nucleophilic. It is negatively charged, and it will immediately seek this configuration. So these 2 configurations are in resonance, so they're flipping to each other back and forth. And in one of those cycles where it is in this configuration, this nucleophile will now attack this carbon, and we will have now a phenol, an OH, an OH, phenol, my carbon, the hydrogen, the chlorine that just added to it, and the same stuff that we had before, which are those two things. Notice also that I started with an acid. Okay, so since I started with an acid, that means that most likely I now have a base, right, somewhere floating, because this had to be gotten from something. You know, this product had to be abstracted from a compound, and that compound became a base. So this base will now come here, will take this proton. These electrons are going to go here, and now this is gonna let go of that. And my final product, right, will be my phenol, the carbonyl just reformed, a chlorine plus plus a compound that has the group that just left, which is now on just a leaving group. Okay, plus the leaving group, plus the leaving group. Alright, so that's that. So what were the key differences? The key difference is that aldol condensation happened with a base, and the base attacked the alpha hydrogens, and put my my compound in this resonance configuration. Okay, now I will have a negative on the oxygen, or a carbon ion on the alpha carbon, that will attract that will now be a nucleophile. Okay, carbon ions are very nucleophilic. In the case of the nucleophilic acyl substitution, I will not have carbon ions, I will have carbocations, which means that they are electrophilic, they attract nucleophiles extremely well. So now I have, so in the case of so aldol condensation, I had a base that attacked the alpha hydrogens. In nucleophilic acyl substitution, I have my carbonyl compound, and I have an acid instead of a base, and the acid and the electrons from the carbonyl compound, from the carbonyl oxygen, will attack and will abstract the proton, and that way the carbonyl compound will become activated. That's what we call it. Now that it is activated, we have a now it will put the compound in this structure that we already went over. And now, and when this, in one of these resonance configurations, instead of being a carbanion, okay, it will be a carbocation. Okay, carbocations will attract nucleophiles. Nucleophile will come in, attack there. It will now. Okay, will attack there and will relieve the carbocation. Then the base that this proton came from, the compound that this proton came from, will have became a base, and that base will come in and grab that hydrogen that's on the oxygen. The electrons from the hydrogen will come and reform the carbonyl double bond, and it will let go of the leaving group, okay, and it will now that leaving group will have been substituted by the nucleophile.